Okay, so today we're going to check out section 4.1, inverse functions. So what exactly is an inverse function? Consider the two functions f and g. They are inverse functions if, whenever the pair AB satisfies y equals f of x, the pair BA satisfies y equals g of x. In other words, the x values become y values, the y values become x values. Another way to test is f and g are also inverses, is f of g of x equals x and g of f of x equals x. We use this symbol here. That's not f to the -1 power. It is a way to denote f inverse of x. A function has an inverse if the function is 1-to-1. Remember when we talked about functions, in order for a relation to be a function, for each x, there was only one y. For a function to be 1-to-1, we also need for each y only one x. So we can determine if a function is 1-to-1 graphically by using a horizontal line test, similar to the vertical line test as well. So let's look, see what we have here. Determine if the function defined by the set of ordered pairs has an inverse. If so, find the inverse. So first, we're told it's a function, so we don't need to test that. Now we need to look for each y, is there only one x? Well, for 8, there's only one x2. For 9, there's only one x3. 10, there's only one x4. And 11, there's only one x5. So yes, there is an inverse, and that inverse would be the set containing 8, 2. We just switch the x and y's. 9, 3. 10, 4. And 11, 5. That's all it is. Okay, what about this? Again, determine if it has an inverse. Now looking here, I have 7 with a x value of 4. Here I have 7 with an x value of 3, so no, there is no inverse. Given a graph of f of x, determine if it's 1-to-1. Again, that was the horizontal line test. Draw horizontal lines. What do we got going on here? Crosses in more than one place, so no. Okay, how about here? We're okay, so yes, this is 1-to-1. Okay, another way to determine if f and g are inverses is to find f of g of x, and it should equal x. And then find g of f of x, and that should equal x. So f of g of x is simply take, for f of x, plug in every value of g, for x, plug in g of x. So we have 4 times x, which is x plus 1 divided by 4, minus 1. And if this equals x, we're okay. So what do we do? Well, this and this canceled out, and I get x plus 1 minus 1, which is x. So far, so good. But we also have to test g of f of x, which means for every x in g, we plug in f of x. So that means this is 4x minus 1 plus 1 divided by 4. 4x minus 1 plus 1 over 4. 4x over 4, which is x. So yes, they are inverses. Okay, now let's look at one a little more difficult here. Let's start out with f of g of x. which is -1 over 1 minus x over x plus 1. So if we take this and multiply it by x over x, to start with, I get 1 over 1 minus x plus x all over x. Continuing on, get -1. This is 1 minus x plus x over 1 over x. Multiplying by x times x, or x divided by x, I get negative x over 1, which is negative x. So this is not inverses. I need positive x. Just to be sure, we can go ahead and do g of f of x to make sure. So this is for every x in g, we place f of x. So I have 1 minus 1 over x plus 1. Wait a minute. 1 minus, hold on, where am I? Here we are. 1 minus -1 over x plus 1 over -1 over x plus 1. So if I go ahead and multiply this and multiply this by x plus 1 over x plus 1, I get x plus 1 minus a -1 over x plus 1 over -1 over x plus 1, which gives me x plus 2 over -1, or negative x plus 2, which again is not x, so therefore not inverses. So we found the inverse when we had a set of points. How do we find the inverse when we have an equation? So let's see, finding the inverse. The first step is to switch x and y, solve for y, then replace your y with f inverse of x. The domain of f is equal to the range of f inverse, and the range of f is equal to the domain of f inverse. So we can graph these using the techniques that we've learned earlier. So find the inverse of the following functions, state the domain and range of f and f inverse. Well, let's start out. We have f. So what's the domain? Well, the domain is -infinity to infinity. It's a line. The range is also -infinity to infinity, which means that f inverse domain will be the range, and range will be the domain. Of course, in this case, it's all the same. So now let's find f inverse. So we take this and make this y equals the 6x minus 2. Then we swap x for y and y for x. So we have x equals 6y minus 2. Now we want to solve for y. So add 2 to both sides. X plus 2 equals 6y. Then divide by 6. So I get y equals x plus 2 over 6, which tells me that f inverse of x equals x plus 2 over 6. Okay. Now let's look at another one here. I have f of x equals 4 over x plus 2. So my domain, x cannot be -2. So my domain is -infinity to -2, union with -2 to infinity. My range, on the other hand, can be anything. Negative infinity to infinity. Now remember, the domain of f inverse is the range of f. So negative infinity to infinity. And the range of f inverse is the domain of f. So negative infinity to -2, union with -2 to infinity. So let's see what happens here. Okay, so I have y equals 4 times x plus 2. I change my x and my y. So I get x equals 4 over y plus 2. I want to solve for y. To do that, I need to multiply both sides by y plus 2. Okay, so I get xy plus 2y equals 4. Now, if I factor y out here, I get y times x plus 2 equals 4. So y equals 4 divided by x plus 2. That doesn't make any sense. Let's look. Okay, y equals 4, x plus 2. Change the x with the y, we're good. Multiply by y plus 2. We're good, we get 4. This breaks down to y times x plus 2. Okay, so that is correct. So f inverse of x is equal to 4 over x plus 2. You don't see that very often. Okay. Look at another one here. Again, my domain, I have x minus 4 here. We can make this a little bigger, right? No, that's a little too big. So I have x minus 4, so that means x cannot be equal to 4. So in my domain, I have negative infinity to 4, union with 4 to infinity. My range, on the other hand, can be anything. Negative infinity to infinity. Actually, that's not true. And neither is this. Because this will never be 0. So we need to change the range to not include 0, and then the domain of f of inverse of x to not include 0. Likewise, our range, this will never be 0. Or will it? Yes, it will. This will be 0. That one, the first one won't be 0. This can be 0 if x is negative 2.5. So now swapping them, we have negative infinity to infinity, negative infinity to 4, union with 4 to infinity. Let's go back for a minute here. Explain this a little better. If x is infinity, we still have 4 over infinity. So it's pretty close to 0, but it will never reach 0. And that's why the range cannot include 0. There's an asymptote there. Here, however, our numerator can equal 0. So now let's break this down. Set it as y equals 2x plus 5 over x minus 4. Swap our x's and our y's. We get x equals 2y plus 5 over y minus 4. We'll go ahead and multiply both sides. by y minus 4. So I get xy minus 4x equals 2y plus 5. Okay, bring this 2y over. I get xy minus 2y. Add the 4x to both sides. 4x plus 5. I can factor out my y and get x minus 2. 4x plus 5. Divide. Y equals 4x plus 5 divided by x minus 2. So f inverse of x is equal to 4x plus 5 over x minus 2, which brings us to another issue. X cannot equal 2. So we need to break this even further. Negative infinity to 2, union with 2 to 4, union with 4 to infinity. Still cannot be 4 either. So let's look at this. Another one. We have f of x equals the square root of x minus 10. And we're saying x must be greater than or equal to 10. Find f inverse of x where x is greater than or equal to 0. So remember, we're talking positive square root only, which is why when we change, remember this is y equals the square root of x minus 10. So we're talking positive only. So we're going to limit our x's to being greater than or equal to 0 once we change this to this. And our y must be greater than or equal to 10. So I square both sides. I get x squared equals y minus 10. Now remember, we're talking, so y equals x squared plus 10. F inverse of x equals x squared plus 10. Where x does not, x is greater than or equal to 0, y would be greater than or equal to 10. We don't really need to worry about that. And I believe that is it for this one. So that's all for this section. As always, have a good day, and I will see you next time.